You are someone who has used multiple large language models over different platforms like ChatGPT, Claude, DeepSeek. Then you must have observed that they all feel a bit different. ChatGPT writes very natural emails, while Claude is praised for writing excellent code and understanding long documents. DeepSeek gives its line of thought before giving response, and Gemini works well across text, images, and the Google ecosystem. Now, the question is, aren't all of these large language models, all of them have been trained to predict the next token? Why don't they behave exactly the same? All of them have. Let's understand why. Large language models, or LLMs, are artificial intelligence which are trained on a large or enormous corpus of text so that they can learn patterns in a language. Making a large language model involves a series of steps. The first step involves collecting data, which is text data, and it could be of various forms. You can collect text data from books, websites, you can have code snippets, tags, research papers, etc. And once this text corpus is collected, it is processed and cleaned and then broken down into what's known as tokens. The tokens would be words, subwords, punctuation marks, symbols. These tokens are then used to train the model. During the training phase, the model does one task repeatedly. What it does is it will predict the next token. And after seeing a large amount of tokens, it starts learning grammar, semantics, writing styles, and relationships between concepts. Once the pre-training is done, that is not the end of the model. Then some fine-tuning is done by companies to make it domain specific or task specific. And then it goes through a series of testing and evolution where it receives human feedback to decide which response is better to certain query. Once this entire pipeline has been done, then the model is packaged into an application, which is the interface that you see in ChatGPT and Claude, where you can directly interact with the model. All of the chat interfaces that we've used so far, they have gone through the step that I mentioned, but somehow they feel different in the way they perform the task. Understand that. Let us imagine there are five students who have learned English, and during their summer break, they've got the assignment to read whatever they like the most. Student A here spends most of the time reading novels, and over the time, they gradually learn to express creatively and write in a smooth manner. Student B spends all the time reading legal documents and develops a formal writing style and also learns domain specific vocabulary. Student C spends most of the time reading about problems and code and develops a reasoning and accurate logic building skill. Student D spends their time reading research papers and develop step-by-step reasoning. And student E spends their time reading conversational chats or customer support chats, and during that, they learn to communicate in a free-flowing style in a helpful manner and keep the conversation going. But notice here that all these students, they learned English, but they develop different strengths because they spend, depending on what they spend most of the time reading. Depending on the corpus on which an LLM is trained, the architectural design, and the fine-tuning that they have received for specific tasks, LLMs can be bucketed into different categories. We can classify LLMs based on the purpose that they solve. For example, there can be simple foundation models whose task is to generate the next token. There can be instruction given models which can receive an instruction, and based on that instruction, they will respond solving a particular task. There can be chat models which can keep a conversation going, and then there can be reasoning models which can think step by step. Based on the architectural design, models can be encoder only models, decoder only models, or a mix of both, or a mixture of experts. So LLMs are based on the transformer architecture, and this classification emerges from there. By the kind of input an LLM can receive for process, LLMs can be a text-only model, which can only comprehend and generate text, and there can be multimodality models, which can handle even images, videos, and audios. The performance of the LLM is also influenced by the size of the corpus that it have been trained on and the size of the model itself. So if the model is huge and it requires data center for the kind of processing that they do, then those kind of models are known as frontier models. And if the model is a small scale, lightweight model, which can also be run local on a system or on mobile devices, then they are the small efficient models. Now, frontier models usually don't release their rates publicly. You have to pay or buy a subscription to be able to use their model through an API. And then there are some models that have released their weights publicly, and you can use them under their terms and conditions. So by the openness of the weights, the models are classified into open weight or closed or proprietary models. Then based on the specialization that the model has, they can be classified as general purpose models, which can handle different tasks equally well. Like they can also chat, they can summarize, they can answer some questions based on some different kinds of domains. Then there could be some domain-specific models which have been trained specifically using the corpus of that specialization. Like if a model is can answer questions related only to medicine, it has been trained on corpus that has been received from medical websites, etc. So, similarly, there could be models that are domain-specific to code or legal aspects. So now we have a picture of why all of these different LLMs seem to have a different personality of their own. In the next video, we will go deeper into how these models are classified and which model comes under which category and how it influences which model we select for a specific application. So next time you think of doing an AI project and you have your problem statement in mind, instead of thinking which model is the best, think which model is best for my application. See you in the next video.